Good evening, everybody. My name is Tim Chan. I'm from the Methanol Institute. Thank you for joining us today on today's webinar. Today's webinar will focus on India's inland waterways and how methanol can play a role as a strategic fuel moving into the future when the country decides to utilize to a greater extent its inland waterways for the carrying of freight, cargo, and even passengers. So as mentioned, my name is Tim. Thank you for joining today. We've got three very good speakers today lined up who will share about their experience with, firstly, domestically. We have Commander Praful Tayal, who will share about his experience with the inland waterways in India. And we have two gentlemen from Sweden, Sebastian Verhelst and Bengt Ramne, who will speak about the conversion of existing marine vessels to be fueled by methanol based on their experience in projects in Europe. So without further ado, I will sort of kickstart today's webinar. Just as a quick introduction, I will give a short brief about who Methanol Institute is and what we do. We are the Global Trade Association for the methanol industry. We've got 4 offices around the world. I'm based in Singapore, but we have offices in Washington, DC, Brussels, and Beijing. And soon we will have one in Delhi, India. So that will be interesting and something for our friends in India to look out for. So our role really is to facilitate the expansion of the methanol industry by looking at ways in which methanol can be greater utilized as an energy and fuel product, but also protect our conventional markets, which is the petrochemical sector. And as mentioned, we are an industry association, so we do have members from all around the world, and our membership is a tiered membership, so it cascades down from the first tier, which are the largest producers of methanol around the world, to tier 2, tier 3, where you get the smaller producers. And in tier 4, you find a lot of technology providers, some of whom might also have experience with using methanol as a marine fuel. So I won't talk about us for too long, so we can delve straight into the topic at heart today. But this is where we are located around the world, and do feel free to reach out to us if you do have any questions about methanol, the industry, and how we might be able to help you in general. And a couple of things to note before we dive into the content for today, just a little bit of announcement and housekeeping. All participants are muted. There is a questions tab on your control panel on GoToWebinar. So if you want to post your questions, do so in the questions tab. You might have to type it out. Actually, you will have to type it out. And I will be receiving your questions. And at the end of the session during Q&A, I will be conveying your questions to our speakers. Beyond the questions tab, there is also a handouts tab where you'll be able to download today's presentation slide deck if you find it helpful to take reference to. So the first speaker of today is Commander Praful Tayal. He was the ex-commander of CIWTC, which is the Central Inland Water Transport Corporation. So without further ado, Commander Praful, I would pass the controls to you, and you can begin your presentation.
Okay, thank you very much, Tim. I am Commander Praful Tayal. My greetings to all in an Indian Namaste, which is a positive posture for greetings as well as a mark of respect, and also very useful in the times of COVID. I have connected from Calcutta, India for the webinar. I am thankful to the Methanol Institute to give me this opportunity to be a speaker at this forum. Along with other speakers, Dr. Sebastian Verhelst and Mr. Bengt Ramne, along with Tim Chan as moderator, as well as Mr. Chris and Ms. Prakriti, who have taken great efforts to help me. I shall cover my part in following 4 sections. Number 1, I shall quickly run through the history of inland water transportation in India. Number 2, then I shall run through the presentation on the present day IWT sector with some details. Number 3, after that, a few insights about the utility of methanol as an additive chemical to the HSD and use as fuel. Lastly, I shall attempt to submit my recommendations. Now, coming to the presentation. On your screen, you will see a slide which is showing a waterways route in India in the second half of the 19th century. That's about after 1850s or so. You can see wherever the rivers are going, the waterways were going at that time. Next slide, I'll go. Now, this slide is at the time of 1947 when India got independence. Over here, you can see the creation of East Pakistan, and also the railway lines network has been laid up. So that was that time, and thereafter East Pakistan has become Bangladesh. In this slide, you will see a photocopy of a fleet list, which were the two largest surviving companies of those times. One is India General Navigation and Railway Company Limited, IGNR. It was incorporated in 1844 at London. And second is River Steam Navigation Company Limited. It was incorporated in 1862 in London. These two companies joined hands when the times were not good in 1899. I repeat, 1899, and then came to be known as the Joint Steamer Companies. Later on, in 1967, the Government of India took over and created CIWTC, Central Inland Water Transport Corporation. This is a page from the fleet list just to demonstrate. At that time, these old companies were together having about 1,200 barges and 12,000 men, which was one of the largest enterprise in the world of its kind, which was the golden period of IWT in India. This is one picture of a paddle steamer, Frere. It was built in 1835 for the services on the river Indus, the Ganges, to operate. Sorry, I clicked twice. And that is another picture of a stern wheeler. And in 1869, a IWT shipyard was set up in Calcutta named Raja Bagan Dockyard. This has now been given to defense production. So it is now producing warships. Now it may be interesting to know that the port of Calcutta is a deep inland port about 150 kilometers from Sagar Island, and it was set up in 1870, 1 year after the setting up of the Raja Bagan Dockyard, which was the IWT yard. And interesting thing is, if you see a plaque at Singapore port, there it is written that they want to be like Calcutta port. And this is probably the first time ever I have spoken 200 years history in 2 minutes. Okay, next. I am coming to this slide. This is the national waterways in India. There are basically 5 national waterways. National waterway number 1, NW1, is on the river Ganges, Yamuna and Ganges. And the number 2 is in Assam, that is on the river Brahmaputra. In between, Bangladesh is there, and Bangladesh, now the waterways are connected also through Bangladesh. Then major rivers, you can see Ganges, Yamuna on the Gangetic plains, then Brahmaputra, Narmada, Tapi, etc. All these rivers. The national waterways number 3, 4, 5 are also there, but there is hardly any movement on that. Talking about the ports in India, there are 13 ports on the east coast, or maybe 14. Dhamra is not showing here, and 32 on the western coast. The concentration of the ports is mostly in Gujarat, that is the left side of your screen top, where various yard crafts are operating. These are the tugs, water barges, oil barges, passenger ferries, etc. These yard crafts are designed as IWT vessels therefore come in the category of IWT barges. In addition to the above ports, there are two large naval dockyards. One is in Visakhapatnam on the east coast, and second one is on the west coast and in Bombay. Each one is having about 125 to 150 yard crafts. Thereafter, we see on the waterway slide we have seen, there are passenger ferries and country boats. I'll come to that later, which are mechanized. There are various acts in India. The first Inland Water Vessel Act, IV Act, was 1917. Thereafter, it has been amended to 2020. Then National Waterways Act 2016. This National Waterways Act is actually, there were five and this National Waterways. After that, 101 have been added. So this was only a declaration of the waterways that will be developed in future in case. Merchant Shipping Act was made in 1958, and there's also Coasting Vessels Act. In addition, this is all related to the IWT vessels and ships. In addition to that, as so far as methanol is concerned, there is a Poison Act 1919. So there are some issues on the Poison Act which the Methanol Institute may know, and that is to be taken into consideration for sorting out various few things, because people using methanol are also making illicit liquor. Just change the slide, please. I'm not able to change, Tim. Next. Yeah, there are various nodal authorities in India. One is the Director General of Shipping, as people may be knowing, and for the waterways and inland waterways, Inland Waterway Authority of India, that is controlling on the central government of India. And the state-wise, there are inland vessel directors, inland vessel directorates. They do the registration for plying and operation of the vessels. Just to give a small hint, generally, the type of vessels in the IWT sector, the barges, which are single load barges, as you can see in the picture top, and down below tugs of different sizes and different shapes from all sizes. I've generally mentioned the length, beam, depth, etc., and capacity. And the engine power is depending on the capacity from about 400 bhp to 1500 bhp. And important for us will be fuel consumption, 50 to 150 liter per hour, because that's where we are mainly attempting for the methanol benefits. Similarly for the tugs, as you can see, everything is listed. Tim, can you try next? I am not able to do. Now passenger ferries are there, which are everywhere across the river. The right side picture shows the ferry in Calcutta on the Hooghly River, and down below is a small ro-ro type vessel operating in Goa. But there are fewer bridges. Like in entire Brahmaputra, there are only 4 bridges. So crossing by boats and ferries is a way of life, and they are sometimes not regulated also. They are generally unionized, so they are in the local administration area, but there are plenty, many of them. Next. Now this will be one important slide for us to see clusters for the marine fleets. While the waterways are there for the long distances, but most of the IWT barges, tugs, ferries, launches, etc., they operate in and around port area, or for the light dredge. Like Calcutta is a deep inland port, about 150 kilometers of the river. So Calcutta is the hub of the IWT. So is in Gujarat. There are various ports in Gujarat, Kandla, Mudra, Jamnagar, Dahej, etc. And also in Maharashtra, Bombay, Ratnagiri, and other places we have seen. In Kerala, there is the National Waterway number 3, but cargo barges are very few. Tugs are there, and passenger crafts are many, maybe more. Andhra Pradesh on the Godavari River, The cargo barges, as such, I don't think there is anything significant. There are tugs, a few numbers, and passenger crafts are mostly operating. But these passenger crafts are operating in the entire stretch of the rivers. West Bengal has got a large number of cargo barges. Initially, they were small in number. They were also tug and barges combination. Two barges, 750 into 2. With a tug, they were towed. And tugs are there in the port as well as in the IWT sector, and passenger craft ferries, which I have shown as it is. In Bengal, the barges size, which are earlier small, now they are generally about 2,000 tons, 4,000 tons. Somebody is now building 5,000 tons because depth available to reach the Calcutta port is 6.5 meter. So that is where it is. And similarly in Assam, cargo barges, though are there, many are there, but they are not operating within Assam. They are similarly for the tugs. But passenger crafts are regulated ones are maybe about 40-50 numbers, but small boats, ferries are hundreds. And Goa is another concentration area. Goa on the west coast, if you see, it was showing the iron ore, which was going to China and some other countries. So there was a ban on iron ore mining. Thereafter, that business has gone, and Goa has just become 1/4 of what it was. So I'll go to the next slide. Coming to the engine brands in IWT barges in India, in tugs, there are Kirloskar Cummins engines, there are Ashok Leyland, which are all made in India, and now in the newer barges, a lot of barge operators and owners are putting Volvo Penta. So existing engines are Kirloskar Cummins, built at Pune, Ashok Leyland, and then consumption is important because we are interested to use the methanol. So cargo barges, it's just an average. It's because it will all depend on the small, medium, large, but on an average, this is what we can see. So and so passenger ferries, and then we can work out details. Present bunkering system for everything is HSD is purchased, it comes to the petrol pump, it fills to the road tanker, goes to the jetty, through a pipeline, it goes to the barge or tug. And the second option is just little different. From the pipeline, it is taken in barrels in a boat, and it can go to the barge or tug. That's all. Next. Now, this is another major area, major fishing harbors in India. There are a very large number of fishing harbors. There are 5 or maybe more. I'm talking about the large ones. Total about 42 fishing harbors are there in 9 states, 4 on the east coast and 5 on the west coast. And a total fleet of about 200,000 fishing trawlers are there, from very small to good capacity. Because they consume a lot of HSD all the time. They go to the ocean a couple of miles and then they catch the fish, school of fish. There are various crafts in the unorganized sector. The right side picture is showing the picture of Varanasi, where there are many tourist barges. As you can see, small ones which are only controlled by local municipalities, etc. And the left side down picture is in the Sundarbans area. You can see 3 small barges. They are maybe carrying 5 tons, 10 tons, sometimes 30, 40 tons also. And some passenger ferries also you can see. So these are the barges, type of barges which are operating everywhere. So we need to target that where we have to start with, maybe informally, maybe ourselves unorganized, because as such no good policies are there. Okay, my presentation does not end here. I will talk about a few points on methanol, though everybody is more knowledgeable than me because I am only talking about the IWT sector. But whatever little I know, I would like to share with the other participants who may not be knowing or maybe knowing even. I'll just go through. To start with, the Methanol Institute's shortlisting of the IWT sector, inland water transport sector, is a well thought of an idea. All this will have a good potential to supplement the use of high-speed diesel in marine crafts, and later in time use only methanol. As I have learned that methanol is biodegradable and soluble in water. Rivers are mostly having fresh water, except near the tidal region stroke basin. The risk of riverine oil spill will be prevented by use of methanol. As I understood, methanol is soluble in water. It is also understood that M15, which is 15% methanol, is a safe liquid fuel additive and does not adversely affect the engine performance. For example, power, thrust of the propellers. Other two speakers may like to reconfirm this or maybe elaborate on this. It is also in public domain that the government of India has been working on methanol economy to reduce the oil import by 10% within next 2 years, as well as reduce the greenhouse emissions, as methanol is a high quality, environment friendly transportation fuel chemical. It is also a great news that just about 10 days ago, Coal India Limited, a has government of India has come out with a global tender worth about 6,500 crore rupees, which is equivalent to $867 million, to set a coal to methanol plant through coal gasification with a production target of 6.75 lakh tons of methanol per annum. It is also to be set up near Calcutta in India, which is also a large hub of IWT barges, just about 25 to 30 kilometers away from Calcutta. The tender is likely to be finalized in early 2021 to produce liquid methanol of the top grade, grade AA, 99.85% purity. And a better part of this is that Coal India is already in talks with Indian Oil Corporation and other state marketing companies for a long-term tie-up on assured marketing of methanol. I think they will lap it up. I think the fossil fuels may not last another 70 to 80 years in the world, except maybe in the Siberia area of Russia. Therefore, it is all the more necessary to have an alternative fuel energy source. Therefore, methanol is definitely a good idea. It is understood that methanol may offer significant efficiency improvement in the IWT engines, potential in the range of up to 20-25% or so efficiency. The other speakers may like to explain this better. It is understood that methanol may offer significant efficiency improvement of the IWT engines. The other speakers may also speak further on this. India is continuously increasing consumption of petrol and diesel as population is growing by the years. In the next 25-30 years, leading to emission increasing of carbon monoxide, etc. Therefore, methanol will sustain and maybe reduce adverse effect on pollution. It is also understood that methanol burns efficiently in the internal combustion engines with near zero pollution, with no SOx and NOx even. Therefore, India is at the first baby steps now with the blending of M15. As people may be aware that India has got a couple of plants where methanol can be produced. 5 are on the high ash coal, that dimethyl ether, and also one natural gas plant. Cost to produce methanol indigenously shall have to remain competitive with local resources as compared to the petroleum products, so that it is beneficial. Methanol, as we all know, is a chemical name. Methanol India may recommend a few government agencies to retrofit a few barges. This shall have to be a good demonstration for success of methanol. Say initially on the government barges, IWI, yard crafts of the ports, naval dockyards, etc. It is a good news that India still has large coal reserves and not very far from the proposed Coal India Limited plant in West Bengal, along with local resources. Though methanol is poisonous to inhale, so is LPG, but methanol is more. So necessary precautions will have to be indicated to everybody who are using. Without mentioning Corona times, things may not be complete. In these times, private investment may not come through. It's up to the government of India to take it further during and past COVID. Now, I have got certain recommendations which the Methanol Institute may like to study and then maybe accept a few, because I do not know much about that. Recommendations, I'm saying number one, let M15 be an additive chemical to be blended with HST initially for 2-3 years so that it doesn't attract taxes and duties similar to diesel, to remain cheaper, to give operating benefits to the barge owners operators. Number two, after the benefits are reaped and understood, retrofitting of the existing engines of the barges may be taken up under some draft policy. Number three, the Methanol Institute should also speak to Indian engine manufacturers to produce suitable engines for methanol in future. M15 may also be sold in small packs. I do not know, this is just out of the box. Small packs of 5, 10, 20-liter packs and maybe 200-liter drums for use in small crafts, barges which are not, which are very far maybe. Usage of M15 has to merge within the existing markets and logistics, etc., to facilitate smooth sale purchase and transition. And maybe some pros and cons may be examined. Methanol India may prepare some awareness programs for Indian IWT industry through IWI or some other means, and along with various states. The Methanol Institute may recommend some policy guidelines on IWT sector regarding potential usage of methanol, both for short term and long term. In my opinion, the largest ocean-going ships must be targeted first, as the largest 100-150 odd ships are producing the maximum pollution of the world, damaging the environment. As much as one largest ocean-going ship may be producing more pollution as compared to all the road vehicles of any one largest metro of the world. To be run fully on methanol, that should be the aim. While it's a good idea to target other sectors also, for example, IWT sector, however small it may be. A look may also be given to the Poison Act 1919, which I have already said before about this illicit hooch, etc., which they are producing. I conclude with a Jai Hind, Namaskar. Thank you very much.
Thank you, Commander Praful. Thanks for setting the tone for the rest of the webinar. I mean, I think your introduction to the inland water sector of India is very helpful in understanding where we're going with this and why methanol can be used as a fuel for inland waterway vessels. Commander Praful talked about bunkering for a short bit, and off the top of my head, I thought it might be good to give participants a reminder that MI has just produced our own bunkering guidelines for methanol. And if there are interested stakeholders on the webinar who are interested in these guidelines, please do approach us. We do advocate for the safe and safe use of methanol as a fuel in different applications. So next up, we have Bengt Ramne from Scandinavian. He's the managing director and naval architect at Scandinavian. He's based in Sweden. Bengt, you've had a couple of years, or actually quite a long experience with methanol on various projects. So today, Bengt will be sharing with us his experience with converting vessels or retrofitting them so that they can be fueled by methanol. So Bengt, the floor is yours.
Thank you, Tim. Thank you very much. And thank you to the Methanol Institute for giving me this opportunity to present what we have done when it comes to methanol as marine fuel. And thank you to Commander Praful for the introduction and setting the tone and the scene. My name is Bengt Ramne. I'm a naval architect. And as mentioned, I am, can I change the slide? Okay. I'm the managing director of Scandinavian AB. We operate out of Gothenburg, Sweden. We have some partner companies in the continental Europe, in Italy, in Barcelona, in Spain, and in Croatia, in Split. As mentioned, we are naval architects. We work with ship design in general. We look into marine transportation systems. And for the last number of years, we have been main focus on how to reduce the environmental and climate impact of shipping. Next slide, please. There you go. It started with a project called F-Ship. F-Ship, the main objective was to support the development of a sustainable and successful maritime transport industry one which is energy efficient and has minimal environmental impact. So in this project, we looked into a lot of aspects for the shipping and impact it makes. We had looked into exhaust gas cleaning, waste heat recovery. We put sails on the ship, but it's quite clear that the major impact from shipping is due to the fuel and what type of fuel we are using. We made a quite broad review of what was possible alternative fuels to the existing fuels, and we soon got our eyes on methanol. And we also got read the book Beyond Oil and Gas, The Methanol Economy by George Ola, Alain Gompert, and Soraya Prakash, which gave us a lot of inspiration and let's open our eyes for the potential and the benefits of methanol. So in principle, what was appealing with methanol is that we could see it's a globally available energy carrier. It's relatively easy to produce. It's easy to transport and store because it's liquid at normal temperature and pressure. You can see that it's a clean fuel. It doesn't contain any sulfur, so we will not have any SOx emissions, and we will not have any particulate matters. We also realized that we will significantly lower the NOx emissions compared to oil-based fuels. And not least, by those things we have covered the environment, but we also need to take care of the climate, and that's one of the really great benefits with methanol. It could be produced in large volumes in a sustainable and renewable way. So that's why we sort of started to look into methanol, or that brought methanol into our interest. Can we change slide there? Yeah. So yeah, there we go. So I'm not going as far back as to 1800s, but we started this in 2009, this F-ship project, and since then has been involved in a number of projects. So in the F-ship project, we had good partners at Stena and Stena Line, Lloyd's register were there, and a number of other relevant companies. And they shared our interest in methanol, and we then could make some consecutive projects together with Stena. The first one was the Stena Scanrail, where we tested some ideas, and that eventually brought us to the more significant conversion of Stena Germanica. Stena Germanica at the time was the second largest RoPax vessel in the world, and we made that conversion starting in 2013, and it was completed in 2015, where all the main engines were converted into methanol operation. At the time, Methanex, they got to see the benefits of this as well, and quite similar in time, they ordered a number of product tankers that would also operate on methanol. Things have, let's say, the oil price is a lot of development. In up to 2013, we had quite high oil price. Unfortunately, I must say that oil price dropped, which sort of reduced interest in commercial applications for methanol. We could see that, and our what we had to do, instead of looking for the big commercial operators, we're looking into the operators, the government and the municipal funded operations like road ferries, pilot boats, where we could see that they need to be the driver to move into this more environmental friendly, climate friendly fuel. So, and then this is projects we have done, and I'm happy to say that we also now have a good portfolio of ongoing and future project within the fast water, which I think Sebastian will talk more about, and this U-turn project, which I will get back to. Okay, next slide, please. This is the Stena Germanica. This size of vessel, we are the naval architect, so we did everything except the engine conversion. When it comes to methanol, it's a different fuel with different characteristics from fuel oil, so you have to do some design changes or adoptions in order to take care of the specific characteristics of methanol. Such things are that we have to have another type of fuel tanks. We cannot use the location of oil fuel tanks, but we can use ballast tanks for methanol. We need to have a separate pump room, and we need to have double wall piping. There are some of the details we have to take care of. It's not, let's say this is the first of a kind, so there was quite a lot of investigations how to do it. It's not very complicated. If you know what you're doing, that you can find solutions to this quite efficiently. The engine itself was a 4-stroke Wärtsilä engine, and Wärtsilä did that conversion. Next slide, please. Oh, there we go. There we go. So this is the 4-stroke engine that Wärtsilä converted, said S40 engine, and let's say methanol has different combustion characteristics than oil fuel. It doesn't compression ignite as easy. It's more of an auto fuel where you would need some help to ignite it. There are different ways to do this. Pilot fuel is one way to do it, and also introducing pilot fuel could be done in different ways. Wärtsilä has a very clever way to do this, very ingenious fuel valve, where you actually have both the methanol and the pilot fuel or the diesel fuel in the same valve. So the conversion of the engine in principle meant that we kept the diesel fuel system and we added on a common rail methanol fuel system, and then we combined the fuels in this fuel injector fuel valve. A very, let's say, very nice way to do it. Then other, let's say, concept for larger vessels is where you have the 2-stroke engine, and that example we had from the Methanex ordered product tankers, where MAN delivered the methanol engine, and the similar concept where you have both the methanol and the diesel combined in the combustion in the cylinder. But the difference here is for a 4-stroke engine, you have quite large cylinder heads, which means that you can have separate injectors for the methanol and for the oil or diesel fuel, which sort of make things a little bit simpler in one way or more complicated. But this engine now it's ordered, it's in the brochure in the portfolio, and I think at this point 11 has been delivered and another 6 at least has been ordered for vessels, product tankers that would operate on methanol or diesel fuel. The next project, as I mentioned, we're moving from large to small. You can see in this slide, you can see both the Stena Germanica, that we made a conversion, and then we have the green pilot boat in the foreground. As I mentioned, when we moved from the big to the small, we moved from the commercial operators to the government-owned funded operations like the pilot boat operators. And there from the Swedish Maritime Administration, we got this pilot boat, and it's an aluminium vessel. It had 2 Cummins engine with about excess of 1,000 horsepower on 2 Cummins engines. And we got that project, and we executed that project where we then tested methanol engines in this vessel. So in principle, we replaced one of the diesel engines for methanol engine. We tested actually 2 different types. So when you do this, when you change fuel, you have to consider the characteristics of methanol. One key thing is that the flash point is 11 degrees. And normal marine fuel, we have a flash point of at least 60 degrees. And all the rules are shaped and set up in order for fuel that has a flash point of 60 degrees or higher. So 11 degrees, we have to do something. However, 11 degrees is not extremely low. We can compare to gasoline, which is minus 40 degrees, and LNG minus 188 degrees. So by opening up for LNG, we say that it's open up for all other kind of low flash point fuel. Another characteristic with methanol is low flame visibility. You can you can see if you have a fire. So that's something we have to be careful about and see, and a risk we have to take care of. We have no smoke from combustion, which is one of the benefits, of course, but it's also a risk. It's making it more difficult to detect a fire. We have some issues with material compatibility. It's not very difficult, but you have to be careful. Methanol is toxic. It's not very toxic, but that issue comes up all the time, and you shouldn't drink methanol. You shouldn't drink any fuel. But it's not extremely toxic, or it's not very toxic, and there is good ways to take care of it. And you should know that methanol is handled in bulk. It's one of the largest commodities that is handled. It's soluble in water, which actually is not a problem. That is a benefit. So how to take care of this characteristics? We have, due to the low flash point, we have a separate tank room. It's gas-tight tank room. We have double wall piping in the engine room. We have provided tank inertia, which means that we have inert gas in the tank space. We have methanol vapor detection, and we have updated the fire detection and suppression system. And then all valves, pipes, and tanks are of stainless steel. So this is the green pilot. If you cut it in half, as it looked before we started to convert it. We have 2 times 600 liter diesel tanks, and we have one engine each starboard and one side port, and we have a fire suppression system of carbon dioxide. So what we did in this ship, we put in 2 new methanol tanks in a separate tank room, gas-tight tank room. We fitted a pump chest, as we call it, in the engine room, the gas-tight pump chest, where we had the filters, the valves. We fitted double wall piping for the fuel piping, all in the engine room, up all the way to the engine. We have gas sensor for leak detection, and we have this tank inertia system where we put an inert gas bottle on deck. For the improved fire safety, we added heat detectors, and for the fire suppression for the foam system, we have to replace the ordinary foam with alcohol-resistant foam. This is all straightforward, and it's let's say if we take care of it, it's very minor additional cost, I would say. On deck, we added a dry disconnect pumping connection, which means that we will not have any spill. We have a pressurized fuel tank, so it means that we need to have a PV valve. And as mentioned before, we have a CO2 system, which actually was oversized, so we could use the existing system. Otherwise, comparing to diesel fires, to suppress methanol fire, you have to use more of the CO2, so you have to upgrade that system. And there are some minor things that you have, an eye wash station whenever you have methanol, because you have to consider the chance that you have a spray of methanol and you get it in the ice. It's important to clean it as soon as possible. Gas detection is one of the things that we put in. It's actually quite straightforward and also a very good way to identify if you have any leakages. In addition to the engine and all piping system and inert gas, we provided a control system. It's included a gas detection and all the controls with valves and fuel tanks in the ship. So this was the scope of the Green Pilot vessel. It's a great project, and our experience is that everything works very well. We didn't actually have any problems with any of the systems. We could realize that in certain conditions we have lower noise from methanol. We feel that we took good care of the material compatibility by providing good right quality for the piping and for the polymers for the plastics. We have to replace some of the sealings, but we know where that is and we can take care of it, so we don't see that as a problem. We know it's easy to detect methanol leakage with a gas detection system. We come up with a simple bunker solution that worked really well. And we do actually not see that inert gas system is needed on this size vessels. Could be, we have it on the smaller installations, but we don't really see, we think that's over problematic or over engineering. We think that in this size, small, limited volume tanks, we should not need a nitrogen inert gas system. So comparing what we did, compare two different engines. As mentioned before, methanol is an auto fuel. It's good to it works well with spark ignition engines. So that's the first engine we tested. We have good experience from that. We have actually quite good fuel efficiency we could prove, but that's actually at high power outtake. We did then also install a compression ignited methanol engine. And the way to make methanol compression ignite is to add an ignition improver and then to increase the compression ratio. So then we took a Scania marine diesel engine and we made those changes. We changed the pistons, we had to change the injectors, and we changed the control system. But this compression ignited methanol engine is really the one we prefer, because you have very good driving performance, you have identical driving performance as for a diesel engine, and we have high efficiency both on high loads and on port loads. And all this experience we got both from the green pilot vessel we are now putting into this U-turn. It's a German research vessel from the Alfred Wegener Institute, ordered by the Alfred Wegener Institute, will be built at Fassmer shipyard and will be fitted with two V8 Scania converted methanol engines. When it comes to our what we have seen and done in India, we have actually been involved, quite heavily involved, and we have far developed projects together with Indian authorities, with the Niti Aayog, with the Inland Waterway Administration of India, and together with Cochin Shipyard, plans to have demonstrators to show the benefits of methanol. We acknowledge that there is a push in India to change to methanol for transportation fuel in all transport sectors, and we can see that we can contribute in the marine sector, and particularly for the inland waterways, where we understand that the ambition is to increase the utilization of the inland waterways. I think now 3% of they contribute with 3% of the total transport work, and I think the target is 15%, and that would mean that a lot of new inland waterway vessels will be needed to be ordered and built, and that of course should be done with a clean fuel and a fuel that could be domestically produced in India. This is the type of vessel that we see that we can provide both the design, the system design, and also the engines. So what we now have in our portfolio is the Scania brand. We have the Scania portfolio of engines from 175 kilowatts to up to the V8 that gives 450 kilowatt. And we can deliver those both as propulsion engine and genset engines. And if you hurry up, I think we can squeeze in the order and get you an engine before Christmas. And with that, I say thank you very much for your attention.
Thanks, Bengt. Thanks for the wonderful presentation. Next up, we will move on to Sebastian. Sebastian is the associate professor at Lund University, but he is also involved in methanol for a couple of years right now, and there is an ongoing project, and I think we would really benefit from hearing about it. So let me just transition the slides to your deck. There we go. And the floor is yours, Sebastian.
Thank you, Tim. Hi, everyone. Thanks for joining in. What I'll try to do next is three things. First of all, present the fast water projects, what we're setting out to do. This is a 4-year project that just got started last June. So we're just getting started. I'll lay out the plans. This is, of course, building from a lot of previous projects, such as Bengt was just explaining. So it's great that he already covered a lot of the technicalities and the benefits of methanol in general. What I'll do at the end is try to sort of zoom out a bit and try to see how our project could actually benefit other initiatives out there, and we're very eager to support those. But first of all, I would actually like to explain you a bit about the lead up to this project. So we've already gone into the details of methanol as a fuel, concerning fuel properties, for instance, which are advantages, which are perhaps challenges, but I would like to take it one step further, or further back actually, and first zoom out on how you actually land onto methanol as a great choice for a future fuel. And of course here the focus is on ship propulsion, but I think it's valid also for other means of transport. And so we've been studying various alternatives out there that could be used as future fuels. And over time, what I've sort of landed up to is what I call my triple S criteria, sort of a set of 3 criteria that I have at hand to judge any criterion or any alternative that comes along the horizon. So remember that, of course, long term, we must be looking for suitable energy carriers, suitable powertrains for transport in general, and in this case for waterborne transport. That's what we're focusing on here. So what are these criteria that we should be handling to make sure that we land up with choices that are truly long-term, that are truly sustainable? Well, first of all, obviously sustainability. So the things that we come up with, we have to study both the energy carrier, so the new fuel, for instance, as well as the propulsion units, the powertrain. We're going to need resources, materials to build these things. We should be able to do that in a closed cycle, so that if we've done our homework correctly, that we can use these things indefinitely, basically. That in itself is not enough. The second criterion that we need, and I feel is still missing from quite a lot of studies, is the scalability. We do use vast amounts of fuel now. There's huge amounts of vehicles out there. The number of ships alone is already mind-boggling. So anything that we can come up with in terms of an alternative, we have to make sure that the resources or the materials that go into producing these alternatives, we don't just are able to use them in a closed cycle, but we also have to make sure that they're abundantly available, because we have to be able to scale them up to these huge quantities. And of course, affordability then goes along with that. If it's abundantly available, it should become affordable. And then a third criterion is, of course, as soon as we're talking transportation, we need something that is sufficiently compact. So storability is then a third thing. Anything you come up with, does it offer enough energy density and enough power density so that it's compatible with the current ship designs, for instance, or at least that you come up with feasible ship designs. And that can be quite different from when you compare a very large container vessel to a small workboat or a pilot boat, for instance. So if you combine these 3 criteria, I believe that a very logical conclusion, first of all, is that we will always have a need for fuels. Whereas, for instance, for passenger cars, maybe we can go a long way with electrification. For something like waterborne transport, we really need the energy density of fuels. So that's a given. And where do those fuels have to come from in the end? Of course, in the long run, we must be able to make them in a renewable way. So you could call them solar fuels or e-fuels, electrofuels, whatever you want. We have to go from renewables such as wind and solar and bio into something that we can use actually to power our fleets out there. So this is sort of the summary of the project core idea of the Fast Water project. This idea that we can produce methanol in the long run, starting from renewably produced hydrogen. So where we start from a renewable electricity form, whether it comes from solar or from wind, for instance, that we electrolyze water so that we can store the electricity when we have an abundance of renewable energy sources in the form of hydrogen, because that's easier to store than renewable electricity. But it's still a difficult thing to store, hence the necessary additional step to something that makes it liquid at normal temperature and pressure. So basically, the way I always explain this, why methanol? Because it's just the simplest thing that you can make that is liquid at atmospheric conditions. So it's a carrier, or it's something to carry around hydrogen. And the most compact way of doing that is by actually having a carbon bond in there. So that's the important bit. Sometimes people criticize methanol by saying, well, there's carbon in there, we have to get rid of carbon. No, we don't want to get rid of carbon. We want to get rid of adding additional carbon to the atmosphere. So as long as we set up a net zero carbon emissions, then we're in the clear. And having a carbon bond in there greatly helps with energy density, with ending up with a very practical fuel, a fuel that can then be used to power marine transportation. So as already mentioned by Bengt, there's been quite a lot of experience by now with methanol as a fuel and as a marine fuel. And at the onset, when we were writing this project proposal, we studied what was already out there to try to understand what are the remaining bottlenecks. And so there's actually three main challenges that we want to tackle by the project. The first one, very practically, is the availability of engines. So we heard the Stena Germanica mentioned, so that has a medium speed engine, but that's not a commercially available engine, unfortunately, currently. The only commercially available engines when we started writing the projects were the huge two-stroke engines by MAN, which is absolutely great that they're out there, but of course they can only be used for really big ships too, whereas we have many more applications, of course, in waterborne. So what we were looking for was sort of the power range between 100 kilowatts to 10 megawatts. That covers a huge amount of applications in waterborne. And that's where we wanted to work on engine technology and on getting these things into the markets. So we'll come back to that in a minute. The second point was that in the long run, we need to make sure that we land with renewable methanol. And so it's also very necessary to demonstrate this full chain, from producing renewable methanol up to distributing it, being able to bunker it on board ships, and then ships actually sailing on this renewable methanol. So that was a second point of attention. Can we demonstrate this entire chain? And then a third point, also really important, of course, these things need to be approved. So you have to look into rules and regulations that you have to tackle before you can actually not just demonstrate, but definitely commercialize these solutions. And so there are some rules and regulations out there. Mostly they have been based on LNG, for instance, which just makes life a bit difficult now, not undoable. It's perfectly doable, but we had the feeling, well, some things are probably way too strict for methanol and we could make life a bit easier, so lower the thresholds to actually people trying out methanol by challenging some of these over strict rules. So that's also something that we want to check during the project if there's any possibility there to simplify procedures. So how are we going to address these challenges? First point, availability of engines, well, here you see three of the engines that we're targeting within this project. The big picture shows a medium speed engine from Anglo-Belgian Corporation, a small ship engine manufacturer. They're going to commercialize a dual fuel version of this engine. So where you have the bulk of the energy being produced by methanol and the methanol being injected into the ports, the intake ports, so that we can also devise retrofit solutions, and then being ignited by a pilot of diesel fuel. At the top right is a Scania engine. So what Bengt from Scandinavius was just explaining, this MD95 concept, where you have a single fuel solution, methanol with ignition enhancer mixed into it, that you can use in a pure compression ignition solution. So that's, as you've just heard, also being commercialized. And then at the top right is a smaller size, 200 kilowatt high-speed engine, a Mercury engine that's going to be retrofitted with a dual fuel retrofit system, because that's one of the things that we also clearly want to demonstrate, that existing ships can be retrofitted to methanol operation. There's a huge amount of ships out there, so if we can make those green, if we can make those less polluting, that's one of the ways to go. The other part, the demonstration of the whole chain of renewable methanol production to its use as a marine fuel, as well as challenging the rules and regulations, we felt that the best way to tackle those is to have some real life demonstrators out there. So at the top left, you see a tugboat that is going to be operated by the Port of Antwerp in Belgium. That is going to be converted and is going to make use of 2 of these medium speed engines that will run in dual fuel operation, each of 2 megawatts power output. On the top right, the pilot boat from the Swedish Maritime Administration that will be converted with the help of Scandinavians to MD95 engines that we just mentioned. Then at the bottom right, a Coast Guard vessel that is going to be operated in the Greek coastal waters and is going to be equipped with this smaller high-speed engine, making use of a retrofit package. And then at the bottom left, you see a river cruise vessel that's going to be a design study to see what it would mean for one of these vessels to actually make use of methanol as the main propulsion fuel. So how has this been translated into the general long-term strategy that we envisage? So first of all, of course, what we're setting out to do is defossilize shipping. And what we're mostly focusing on is these demonstrators. That also means that a number of things are actually out of scope of the fast water project to build or to go to sustainable powertrains for shipping. So we do realize that there's options through electrification, for instance, that there's options through other fuels. That's a bit out of the scope of fast water. What we want to focus on is methanol. We won't do any work directly ourselves on methanol production, but I'll explain you in a minute how we actually make sure that we have that link to what is going on with methanol production. What we want to make sure and what we want to demonstrate is this pathway from methanol currently mostly being based on fossil feedstocks, natural gas or coal, depending on where you are around the world, with then slowly but steadily biomethanol becoming available in the market. We see demonstration projects, pilot plants set up to demonstrate the production of low carbon methanol. So where you start from renewably produced hydrogen and you combine that with a waste stream with carbon content, could be the exhaust stacks from a power plant, for instance. But in the end, of course, we need to be able to end up with new renewable methanol. The great thing here is, of course, that renewable methanol and fossil-based methanol, it's exactly the same molecule, so we can blend these and we can increase the blending, we can increase the share of green methanol in the fuel pool. At the heart of our project is to tackle this first challenge, clearly developing methanol engine technology. So on the one hand, we have these demonstrators that are really geared at demonstrating relatively easy technology to introduce so that we can come to a commercial introduction of these technologies. So we've talked about MD95, we've talked about dual fuel technology using port fuel injection so that we can also commercialize retrofit kits. In parallel, we're supporting that work with a more research-oriented work package looking into advanced engine technologies. So once that we create some market for methanol as a marine fuel, can we go to single fuel solutions? Can we go to pure compression ignition operation on methanol? Can we go to spark ignition operation on methanol to really take best advantage of the properties of methanol, to basically be able to get the highest efficiency out of the engines and the lowest pollutant emissions, so that we can couple that back to our industrial partners and then actually look into the commercial introduction of the best options for advanced methanol engines to really set out the pathway. Where is this going to lead us to? So the way we have organized the project is shown here. So the overall work package structure, I won't go into much details here, just highlight that the core of the project really is these demonstrators of the harbor tug in Belgium, the pilot boat in Sweden, the Coast Guard vessel in Greece, and then the river cruise ship concept by a German shipyard. I'll name the partners in a minute. These are, of course, relying on methanol engine solutions. So there we will make sure that we have commercial introductions. We will make sure that we can offer retrofit packages. Next to engines, of course, there's a lot of other things that we have to organize. We need to take care of fuel logistics. We need to look into standards, acknowledge safety differences with the fuels that we are used to today, and also work on training packages, for instance, for both onshore as ship crew. We're supporting that, as mentioned, with a work package on next generation engines. So what do we learn from the experience gathered during the demonstrations to be able to lead us to the next type of engines that make even better use of methanol's properties. And at the end, of course, we want to make a real business out of this. Our industrial partners see a lot of potential here in methanol as a marine fuel. All right, so just to give you a quick idea, we've just started 1st of June, so we're now very busy developing all the technology, developing all the plans for the demonstrators, so that about a year from now we can actually of course, you can end up with problems like this. I think Tim is trying to get this sorted out. Just bear with us for a minute.
Hi, Sebastian, can you hear me?
Yes, thank you.
Okay, I think I'm back. Okay, Sebastian, I think the last time we stopped, we were here.
A bit later, if you can bring up the next slides completely. You can also run this to the end.
Okay, I think it was somewhere around here.
Yeah.
Okay.
You can move this on. I still don't seem to have any control, so you'll have to help me out here.
Sure, no worries.
I mentioned, yeah, during the introduction that there's a part of the project is actually out of scope of the project consortium, and to be able to cover that, we've actually installed an advisory board. So if you can go to the next animation, Tim. Yeah, so there the idea is that we get some advice, some feedback on what are the best ways to actually go to exploitation, on how we can increase the project exposure, identify some early movers, and push the adoption of recommended guidelines if our conclusions are that some guidelines should be changed. So we have a first group of renewable methanol producers so that we can match these to ship owners, that we can bring these parties into contact, because I know a lot of fleet owners, for instance, have questions on what's going to be the scale of the availability of renewable methanol. So we have a second group consisting of ship owners. We have a third group consisting of authorities, and a fourth group, you can go to the next click, of propulsion technology manufacturers. We have some on board within the consortium, but we also have a couple in the advisory board to try to span as much again of the value chain and make sure that our project results get picked up. Which brings me to the next slide, which is on how this could potentially benefit, for instance, initiatives such as are currently happening within India. So I had put some thought into how we can benefit other initiatives. I think first of all, the fact that we will have high and medium speed methanol engines commercially available already means that we're going to enable a lot of interest to actually be met. Now we unfortunately we have to answer a lot of people with saying, yeah, that would be a great project, but unfortunately there's no engine commercially available now in the power range that you're looking for. So that's one of the things that we want to tackle. And the next one is the retrofit kit. So that's on the same level. Can we convert existing ships, or a ship is up for refurbishment? How can we go to a greener solution? There's not too many options out there, so hopefully within a short period, or sort of halfway during this project, that will become feasible. Next one. I think very importantly, that was something that was voiced by all our project partners, is that there's a real need for real life demonstrators. Okay, there's some out there, but we really need to expand that portfolio. Being able to guide people around the ship, see how it actually looks in practice, see that it isn't rocket science, that it is very achievable, we hope will help generate a lot of interest and this really being picked up. Next one. I also mentioned we're going to develop training materials, so that already exists for some ships, like the big two-stroke engine-equipped waterfront methanol tankers, for instance. Of course, they needed to be able to train the crew, and so we want to translate that experience to also other types of ships, and we also want to make sure that that material becomes available to as many people as possible. Next. We mentioned the rules and regulations. There we think that we can probably lower the thresholds by getting rid of some things that are either very geared towards LNG, which has completely different properties than methanol, being a cryogenically stored liquefied gas. That's quite different from methanol. On the other hand, we also feel that a lot of these rules and regulations are really targeted at very big ships, whereas that there's tons of small workboats, for instance, that where it would be undoable to apply these same types of rules and regulations. And the next one, we want to demonstrate this complete supply chain so that we don't just show that, well, we convert a ship, but we can actually also make sure that it gets regularly serviced, that it gets supplied with renewable methanol, depending, of course, on the interests. Maybe that's something that I need to take a minute for as well. Our long-term aim, obviously, is to be able to transition to renewable methanol. But a big advantage of methanol for a lot of shipping is that even if you convert existing ships to methanol operation and you use currently available methanol, so fossil-based methanol, that you at least can already reduce pollutant emissions very substantially. So NOx emissions, soot emissions, those can go down drastically. Of course, you're not doing CO2 emissions any benefits there because you're still running on a fossil-based fuel, but at least pollutant emissions can go down hugely, which for instance, ports can be extremely important. And then as a final point, of course, we want to develop business plans, and we will hopefully gain some experience that we can also spread out to other partners that are deciding on whether to invest in methanol as a fuel or not. And that, I think, brings me to my final slides. Thank you very much for your attention, for hanging in there during the technical issues, and I look forward to any questions or comments you might have. Thanks for listening.
Thank you, Sebastian. Let me just quickly change the background, but I wanted to pick up on a point that you mentioned during your presentation. And I thought that was quite interesting because, and I quote you, maybe not in the best way, but like paraphrased. You said we do not want to get rid of carbon, but we do. Actually, no. Let me rephrase that. It's not that we want to get rid of carbon, but it's just that we don't want carbon in the atmosphere. And then you mentioned something new to me, which is quite interesting, which is we want to defossilize the maritime industry. And I think the reason why I'm bringing up these 2 points is that I think it's quite interesting to note that sometimes carbon is not always the enemy. Yeah, sometimes you do
Absolutely.
need carbon. You do need carbon in some products. It's essential, and it has been our way of life for the longest time. And without carbon, we're going to see a lot of essential products that are in our lives go missing. So the idea is not to. I mean, it's quite interesting. I don't know if I'll be taking it too far by saying it's not about decarbonization, but it is about defossilization. And then you spoke about the circularity of alternative fuels or renewable fuels. So maybe something that we should be looking at is not just pure decarbonization, but how do we implement or design a carbon circular economy in some ways? Would you agree with that?
I think you hit the nail on the head. I start becoming pretty allergic to this decarbonization term, because then the idea is we need to get rid of carbon. No, the idea is we need to get rid of our addiction to fossil fuel. And so there's plenty of ways indeed to use carbon-containing fuel from biomass, from renewables. The important bit is that we don't add carbon additionally to the atmosphere. So if we can take carbon out by having biomass grow or by capturing carbon to build fuels, then we're in the clear. And indeed, there's a very big reason why we're making use of these hydrocarbon fuels now, because they're so attractive, they're so fantastic energy carriers.
Thanks, Sebastian. Those really interesting points. I just wanted to draw them up because I think sometimes some of these points are important to note. I mean, we're not going completely 0% carbon. We're just limiting the amount of carbon we put into the atmosphere. So at this point in time, I would like to get my presenters back on for a short Q&A session. So if our presenters could turn on their webcam and as well as unmute themselves, let's hope we can get through this 30 minutes without any technical interruptions. By the way, for the people in the audience, we do apologize for that slight technical issue that we did face just now. I hope you did not miss anything much. But if you do have any questions, now would be the time to raise them. So we do have a number of questions from the audience, but I guess I do want to sort of start by giving a couple of comments about some of the materials that we've heard from our presenters today. So the focus really is on using methanol as a fuel for inland waterways. And the dynamics or the circumstances on waterborne transport inland seems to be very, very different from, say, for example, that of ocean-going transport modes. The concerns that they have might be different, and I think there are a couple of questions that I want to ask Commander Praful based on his experience working on the inland sector for many number of years, what his thoughts are. Yeah? So, Commander Praful, there are a couple of things that I do want to clarify at this moment in time. Unlike ocean-going transport, inland waterways can be restricted in some ways when, for example, the channels by which some of these vessels travel through or traverse can be quite narrow. Is that really a huge safety concern when you think about the choice of fuel for inland waterborne transport?
No, I don't think so. The channels are not very narrow. The channels are adequate, and accordingly, the barges ply in them. So, narrowing of channel is not an issue, and also no accidents by colliding into each other.
Okay, yeah. So I mean, thanks for that clarification, because I thought that, I mean, if safety was a concern, then you'd be thinking of the type of fuels that you'd use, and you probably want to use something that's less volatile. But thanks for clarifying that. But so, Commander Praful, while we have you down here, you did cover a couple of, or you did give an overview of the inland transport sector and some of the popular or more commonly used vessel types. Which one do you think would be the low-hanging fruit for the conversion or the adoption of methanol as a fuel?
Basically, we should proceed for the cargo barges, which are the single hull and maybe double screw, twin screw. So these should be first attempted. And of course, fishing, I already said, fishing should be the one, because our consumption of the fuel is maximum in fishing trawlers. I already said that in my slide.
Okay, thank you. So
another thing,
next up,
to supplement another thing, as India has been talking, as I have understood, that we are talking of M15, which is a additive chemical. So that will be the simplest way to proceed without any engine modifications, because you can run the engine after for a couple of 1,000 hours, and then maybe some gasket change or etc. This is what I have understood. Dr. Saraswat had been talking about it.
thank you. Okay, so now I'll
to clarify that. So you're talking about M15, if I understood you correctly?
Yeah, additive chemical into the diesel.
Yeah, but as far as I know, there's quite some limitations to that approach, because methanol doesn't mix too well in diesel. So the percentage of methanol that you can add into diesel that way is really limited, and you mostly need some help from other chemicals like surfactants to end up with a good mixture. So whereas that's a theoretical possibility, there are some difficulties with that approach.
Tim can clarify better.
Sure. Yeah, no, I think no, I think Sebastian, you're right. I mean, but Commander Praful, you did raise a good point too. Yes, there is an issue with phase separation when you mix diesel and methanol, but it seems like there are existing projects in India right now where they're looking at the correct blend as well as the additives that are needed to ensure that the blend remains stable and there isn't that separation between methanol and diesel. So once those projects are completed or the results that are that we can get or the kind of data that we can get from those projects are ready, then I think that the mixture or the blending of diesel and methanol could be something that could be viable in India. From a technical perspective, I mean, that's where the research is focusing on. But if you're talking about wide scale uptake, that would be something that would be left for us to see in the future. So I do want to move on to some of the questions that we have for us today, and we do have quite a number of questions. Okay, let's see this one. What kind of additive was used in MD95, and what was the compression ratio of the Scania 13-liter engine? Bengt, I believe this was directed at you.
So there are a number of possible ignition enhancer to use, but the most widely used is what's called Berade, and that's a product of Neuron. So that's, let's say, we are investigating different options, but currently that's this, let's say, the standard one to use. And then on the Scania engine, I think it's 1 to 26. So normally they would have 1 to 17, and now the compression ratio is increased to 1 to 26. And that's that's things that we will investigate as well, how high the compression ratio really needs to be in different conditions. What we are basing this on now is automotive technology, where you have, at least in Sweden, we have very high demands for cold starting capacity, and we know that for marine application we can solve that in different ways. But currently we are basing this on automotive technology.
Thanks, Bengt. Well, I have you here. I do have another quick question for you. And the question is, what is the development cost of a coaxial injector?
The development,
you have a,
I don't know. We know that the injector that we dual fuel injectors, I know that Wärtsilä spent quite a lot of money on that, and we were lucky because they had done the development for gas diesel injectors, and we could use the same with very little modifications for methanol diesel injection. So I don't dare to guess. It's quite a lot of money to develop that.
Okay, thank you. So let's go on to Sebastian. Sebastian, I guess the first question generally is about the nature of the fast water project. And the question was, could you share more details, such as the number of researchers that were involved in this undertaking, and as well as what the details of the fundamental stages of the studies that has to be undertaken before the project reaches completion?
Yeah, so it's a 4-year project. Has started 1st of June. We have €5 million of European funding for that through the Horizon 2020 program. So we have 14 partners involved and at least 4 to 5 people per partner. So we have about 50 people in all working on this project. The core of the project really is these demonstrators. So and some of them really want to move fast. So both the tugboat and the pilot boat, 2 years from now, they will have been converted. They will start sailing around. The retrofit packages and the commercial engines should also be available at the latest by that stage. Of course, the more fundamental work underpinning that, working on the next generation engines, that will probably go through the entire 4 years. But the demonstrators, the commercial introduction, will probably be halfway through the projects. I don't know if I actually answered your question like that, but you can correct me if I didn't.
I think yeah, I think you answered the main parts of that question. But moving on actually to something that's a bit more interesting, in my opinion, also is, and it's actually kind of something about, it kind of is related to what we were speaking about after your presentation, and that is, please shed some light on how methanol is better than hydrogen as a fuel in bigger applications like ships.
Yeah, I love that question because certainly in Europe for the moment there's a huge hydrogen hype going on, and I like that to some points. I mean, we need to get hydrogen projects off the ground because we need to move to renewable energy sources. We can't just make do with renewable electricity. We need to be able to buffer that energy also, because we don't always have sun and winds around. So we need something to buffer energy, and as mentioned, we need a fuel for that. So the first logical step is definitely hydrogen. But if you try to match hydrogen's properties with direct use of it as a fuel for transportation, then you quickly run into some serious issues. It's well, it's 15 times lighter than air, so it's extremely difficult to store. We already know from the LNG experience that there's a tons of vessels out there that cannot be converted to LNG. So that will just be even worse for hydrogen. It takes up even more space. And it's also a question of the whole life cycle of the fuel. Because if the only way you can make hydrogen transportable and that you can distribute it because of its low density is either also liquefying it, like with LNG, but that means in this case cooling to minus 253 degrees C, which takes as much energy as a third of the heating value of the fuel, or it's going to high pressure hydrogen, 350 bar or up, which also means up to 10% of the heating value of the fuel. If you look into the amount of energy that you actually need to produce methanol from this renewable hydrogen, it's of the same order of magnitude. Whereas once you have methanol, you have something that is liquid. So it's just much easier to transport around, to store on board fuel on board ships. So also your fuel storage system is going to be way cheaper than for hydrogen. And from our experience now, both hydrogen and methanol are fantastic engine fuels. They both allow high efficiencies, very low emissions. So there's no real reason why we should dare prefer hydrogen over methanol.
Thanks, Sebastian. So the next question, I want to go on to Commander Praful. So as India has been working on this National Waterways project, there are multiple national waterways in India right now, and this project has been ongoing for a number of years. I believe it even preceded, I mean, the last formal legislation that has given the government a push was, I think, in 2016 with the National Waterways Act. But this project has been ongoing for a long period of time, for as long as probably India had rivers, right? Because that's when they relied on it for the transportation of cargo and passengers. But what has changed in the last, say, 4 or 5 years with regards to this National Waterway project? And are there any significant changes that would present opportunities for alternative fuels to enter the market?
So far as the rivers are concerned, the rivers were there where they were. The things which are changing is the more on the regulation, then dredging and river training works, and also on the infrastructure side, means building of jetties, the navigation lights, the navigation assisting systems, and other equipment, connectivity of the riverside jetties, the main roads, etc. All that is happening. And also the IWAI, Inland Waterways Authority of India, have built about 30, 35 odd barges with a German design. They are built in India, but design is German. So they are also going ahead in technology. So that is what has changed. But so far as this alternative energy use is there, as such there was no big thrust. But now probably it is being understood and it will come in the times to come. May not be so soon, but maybe 2-3 years to start with. As you said, in Cochin shipyard, maybe some power vessels will be built as it is suitable for methanol. maybe 30-40 barges. But others will basically need to use the methanol as supplementary fuel to add, and then with some modifications to the engine, because ultimately it will be driven by commercial benefits, financial benefits. Because individual barge owner and operator will look into that money, and post COVID the money is hard to come by, so there will be little scarcity of investments.
Yeah, Commander Full, actually, I agree with the point, right? I think a lot of these changes and developments will be really very much driven by commercial benefits. And I think there was one point that I was thinking about during our presentations that I wanted to ask you about, and was that when you were talking about high-speed diesel that's being used in inland waterway vessels right now, what I mean, I understand for transport. I mean, I don't know if there is a difference between land and marine transport and its consumption of diesel, but I understand for diesel consumption in land transport, the taxes on it in India is relatively
Are the
sorry,
same. The
they're the
taxes
same,
are the
and
same.
they're relatively high. Is that accurate?
No, these are the same, but the delivery to the boat or the barge, they charge 2 rupees per liter extra. Extra 2 rupees per liter for that additional delivery charge from the petrol pump or the bunker point to the barge, because a tanker will take it. Tanker of
Understood.
petrol or something.
Yeah, I mean, I think that was something I wanted to clarify because I've had like some conversations with Indian companies who are looking into or at least they want to be fuel providers in India, and one of the main drivers that they told me was that methanol is not taxed like a fuel. Methanol is taxed like basically by GST, which is
Because
significantly lower.
it is still a chemical. It is not a fuel per se. It's
So
still a chemical.
that would be the cost benefits, right? I mean, that could probably drive the market to looking at these
If you market
alternative
methanol
fuels.
as a chemical, then the benefit is there. The day you will convert it to a fuel, the terminology, that other taxes will be applicable. Taxes and duties.
Sure. Got it. Okay, so the next question I have is for Bank. Actually, Bank, I have two questions for you, and I think because they're very, very much related to your presentation. First is, can existing fuel tanks be used in the case of converting diesel vessels to methanol fuel? And the second one is, methanol burns with an invisible flame, so do we need any kind of specific fire detection systems? Bank, I think you're still on mute.
Okay, I'll try again. The methanol fuel tanks need to be double walled, so we need to have a space or a coffer between the inner and outer tank. So it's possible to utilize an existing fuel tank, but what we have to arrange this double wall with an inner existing tank. But that's absolutely doable. Another opportunity or possibility is that on larger ships, fuel tanks are not allowed to be against the shell side due to consequences if you would have a rip up and major fuel spill. That condition does not apply to methanol. So actually we have a lot more freedom to place the methanol fuel tanks than the oil fuel tanks. And it also means that we can convert ballast tanks, normal ballast tanks, to convert to methanol tanks. So that's an opportunity. The other question was about
fire detection. Fire detection on board.
Yes. So what we did, instead of just conventionally just smoke detection, we added on heat detection devices as well. So it's a minor. It's not a costly. It's a minor modification. It's just a design issue, or let's say it's just to select the proper item.
Okay, thanks, Bengt. Well, let me see. The next question, I saw one down here on fuel standards. Oh, I guess I could take that question. So the question is, are there any fuel standards for methanol available? Questions related to bunker quality. So, well, I mean, as it is right now, methanol is unlike your common distillate fuels. Yeah, we produce it chemical grade, with a purity of more than 99%. It can even go higher depending on the final application of the chemical. So in general, methanol is a very, well, I would say, for lack of a better expression, homogeneous product. The standards for methanol as a chemical are widely available, but not as a fuel. So as a fuel, we do understand that on an international level at the ISO, they are looking at fuel standards for methanol in a marine application, but that is not out yet. So that's something that we could look forward to having in the future. But as it is right now, there are existing standards for methanol quality for being used as a chemical, and that same quality of methanol is also being used as a fuel in different applications around the world. So Sebastian, I wanted to go back to you, but I will have to find this question. Because we talked about hydrogen earlier, yeah? How about methanol versus ammonia? That seems to be gaining some traction recently.
Yeah. Maybe first to come back to the methanol versus hydrogen one, maybe it's good to know that I actually did my PhD on hydrogen engines, worked on hydrogen for over 10 years. So it's not just some wild idea. I have a lot of experience also with hydrogen. So it's a very practical thing why I actually now invested in research in methanol. I think it's much more widely applicable. But then ammonia, that's a good one. I think partly it's probably popped up onto people's radar because, again, of this sort of tunnel vision, like we must get rid of carbon, and then another way of turning hydrogen into something that you can store in an easier way is indeed ammonia. There's a couple of things that you have to consider then. First of all, how much hydrogen can you store? And ammonia is indeed pretty interesting then. It is a gas, so you have to also pressurize it to turn into a liquid. So it's a bit like an LPG type storage. So still perfectly doable, affordable systems. But then you also have to look into how much energy it needs to actually produce the ammonia from hydrogen. And there's quite a lot of people have this wrong picture that they feel that it's probably way more efficient to produce ammonia than methanol, because for methanol you need carbon. If you need to capture carbon from the atmosphere, that must be really hard. Well, that doesn't turn out to be the case. Needing nitrogen, and then the nitrogen molecule being a very stable molecule, that means that it takes quite a bit of energy to actually rip open the nitrogen molecule to get hold of the atom to produce ammonia. So if you compare the whole chain, actually producing ammonia is as energy intensive as producing methanol. So we could still say they're equally attractive. Well, the next bit is then, of course, using it as a fuel. And we know from experience that methanol is a fantastic engine fuel, as already been highlighted a couple of times. Whereas if you look at ammonia, first of all, there's way less experience with using ammonia as a fuel. And secondly, the experience there is proves that it's really hard to get it to burn well. So in a lot of cases, you have to either convert it partially back to hydrogen or throw some additional hydrogen in there just to get it to burn fast enough. There is one exception, and that's, again, these huge two-stroke engines where you have, again, a pilot injection of diesel, for instance, and then the bulk of the fuel can be hydrogen or ammonia or methanol. Basically, these engines burn anything. So ammonia also works well there. But anything that will be smaller, that will be the size of engines, for instance, for inland waterway, ammonia is going to be a pretty difficult thing to handle as a fuel. So from a comparison there, again, ammonia really comes out as having a lot of advantages compared to, methanol comes out as having a lot of advantages over ammonia.
And I think if you also toxicity and other hazards, then anyone who have tried to handle ammonia realize the problem, the problems.
Thanks, Bengt. Actually, don't unmute yourself because I have two questions for you. So in your slide deck, you share your experience with both spark ignition and compression ignition methanol engines with similar output. I believe this was the slide where you had the Scania and Weichai. Which one has more potential in your opinion?
Depends. I guess that depends on the time scale and horizon. But I think in the short term, the compression ignited concept is by far the easiest to develop and the what is closest to market. And that's a lot based due to that we have we can build on the experience from Scania with their ethanol experience. When it comes to larger engines, I don't know, and I think probably in the long term it's neither auto combustion or diesel combustion. It will be something in between, and I think that's something they are working quite heavily on in Lund. So I eventually what is going to be the best option, I need to leave open.
Sure. And the follow-up question to that was that comparison, yeah? Can you elaborate a bit more on the comparisons between their performance? I guess that's quite an open question. So maybe what are the probably key differences between their performance, the two engines that were being compared?
I think the main thing is that but at max power or close to max power output, we could actually achieve the same efficiency. But the characteristic of a diesel engine is that we also can achieve high efficiency at port load, and that's quite very significant because most engines will operate at port load. Let's say the other significant difference is that the spark ignited, it's easy to get extremely low NOx emissions. So it's a benefit from the emission point of view that the after treatment, we don't need any after treatment, or it's very simple after treatment. We can have a three-way catalyst to get super low NOx emissions. Whereas for the compression ignited, there is always a trade-off between fuel efficiency and NOx emissions. So getting to the really extreme low NOx emissions, we still will not, probably will need some kind of after treatment, or there will be a fuel penalty. So I think that's the trade-off.
Okay, thanks. So, wow, I do realize that we are quite like over time right now. So what I'll do right now is that I want to thank my speakers. Thank you very much, everybody, for taking the time and coming on board, as well as the audience for taking the time to be here and listen to our speakers. We do apologize once again for the technical difficulty in between. I do know that there are some questions that have not been answered yet. What I'll do is we do have a list of questions from you. We will send it to our speakers, and we will try to get your answers that you want. So once again, thank you everybody for being part of today's session. We hope you enjoyed it, and have a good afternoon and good evening for the rest of us. Thank you.
Okay. Thank you very much. Thank you.
Thanks.
Thank you.